All right, so you can see in my directions here on number 1, it says find the exact value. It's highlighted and underlined. So I have no interest in you typing this in the calculator and getting a decimal. If you do that, like, that's not worth any points. That's what you did last semester. What I'm interested in, can we get the exact value? Now, you can see, starting with 1A, this is a little bit harder than what we did on the notes because degrees are just naturally easier for us. Radians, not so much. Like when we get down to C, how can we rewrite 75 degrees? It's supposed to be the easy one.
It's like 45 plus 30 degrees.
Okay, that will work. So degrees, we can usually just do it in our head. Think of a couple that work. Radians, not so much. You probably can't tell me 2 radians that we know on the unit circle that add up to 11 pi over 12. So here's my strategy. This is what I think works the best. I try to rewrite this, and I just picked 2. I just picked 2 easy ones. Like the smallest one possible, like 1 pi over 12, and then 10 pi over 12. These 2 need to add up to 11 pi over 12. Right? 1 pi over 12 plus 10 pi over 12 is 11 pi over 12. And then I just ask myself, do I have 1 pi over 12 memorized on the unit circle? Okay, then that's not good. But, so I can't work with this. But it's okay because it's still a place to start. So what I would do is make this a little bit bigger, maybe 2 pi over 12, which means this needs to be a little bit smaller because they still have to add up to 11 pi over 12. Now, do I memorize 2 pi over 12 on the unit circle?
Yeah.
Yes. I mean, it's not super obvious, but if you reduce it, you do. And does this reduce to something we know? So, 3 pi over 4. So that's how I like to start these questions off. I don't know. Maybe you're smart enough that you know that pi over 6 plus 3 pi over 4 is going to give you 11 pi over 12, but I can't do that. I have to just start with something, make one a little bigger, one a little smaller, one a little bigger, one a little smaller, and then I always stumble upon 2 that I know. Okay, so if we plug this in, and now on this handout, I'm going to ask that you guys do a little bit more practice, but I'm going to be selective on which parts of each question I want you to do. So I will tell you how it plugs in, and now I'd like you to try to finish the question. Okay, so I'm getting negative square root of 2 plus the square root of 6 over 4. I would suspect if probably the most common mistake is right here, unit circle. You guys know the signs make a big difference. Cosine's negative at 3 pi over 4. So check to make sure you put a negative there if your square root of 2 is positive. And go ahead and review that and see if you guys have any questions. Yes?
Can you go back to the sine formula to make sure I copied it down right for something? Because is it sine of u cosine of v plus or minus sine of v times cosine of u?
Okay, well it's only going to be one of them.
Or that, yeah, that's
Sine, if it's plus, then this is plus. It should be sine of the first angle, cosine of the second, sine of the second, cosine of the first. I mean, I guess it's possible I wrote that one down wrong, but not here, it shouldn't be. Cosine of the first, sine of the first, cosine of the second, same sign as what it's over here. Sine of the second, cosine of the first. Any other questions? Okay, so let's say you had a calculator on the quiz or a test. Again, just because I don't want the decimal as your final answer here, I would still recommend you put this in your calculator, see the decimal approximation, throw this in your calculator, look at this decimal approximation, and they better be the same thing. If they're not the same thing, then you know something was off, and you should go back and try to find your mistake. Okay, so part B, now it's 13 pi over 12. So again, for most people, that's just not easy to come up with two angles that you could quickly add or subtract to get 13 pi over 12. So consider my approach here, which is take like maybe 1 pi over 12 plus 12 pi over 12. Just give yourself something that adds up to 13 pi over 12. This is not a spot I know on the unit circle, so it doesn't matter that this one is, it's not going to work. But as long as you start with something, you can make this one a little bit bigger, change it from 1 pi over 12 to 2 pi over 12. Now I can see that this reduces to pi over 6, so that's good news. But I've got to make this smaller. Do we know 11 pi over 12? No. So it fixed this one and messed that one up. But that's okay, because you just keep going. You make this one a little bit bigger, this one a little bit smaller. It might take a couple tries, but eventually you'll get it to be two things you know. And it may not be obvious at first because you need to reduce. This is pi over 4. This is 5 pi over 6. We know both of those spots. Okay, so I'm not plugging it in the formula for you on this one. I would like you to practice doing that too. Look up the formula, make sure you can plug it in correctly. Unit circle 4 times carefully and try to finish. And if you work a little bit quicker and you have a calculator, go ahead and try to compare decimals as a way to check. take another minute to finish up, and I went ahead and put up my work on the board for you to compare with. So if you disagree with me or you've got a question in there, go ahead and speak up or send it in chat for me so we can kind of iron that out, because we're not going to look at any other questions like this one for the rest of class. This is the last one like this. I guess it'd also be helpful to talk about the calculator here, because I think there's going to be a common mistake with checking your answer in the calculator. So what was the original question? Cosine of 13 pi over 12? Is that it? Okay. Okay, so that's the decimal our answer should be. And then what did I get? Negative square root of 6 minus the square root of 2. And then that was over 4. How come those aren't the same then? Yeah.
Did the square root of 2 divide by 4 first, and then was subtracted from negative square root of 2?
Right, it does order of operations, so it does this first. Yeah, okay.
You didn't put cosine.
Huh?
Well, on the second one, you didn't put like on the top one is cosine of 13 pi over 12.
Uh-huh.
Well, on the second one, you didn't even put cosine, so.
Yeah, it's just a ratio. It's what it equals. You shouldn't have a cosine here.
Okay.
Like when we say what is the sine of 30 degrees, it's just 1/2. It's not sine 1/2. It's just whatever the ratio is. So, right. Just be careful. Anytime you guys have fractions, it never hurts to put parentheses around the numerator and denominator, and sometimes it's necessary like this. It's implied that all of that numerator is being computed first before the division when you make a big fraction like that. So, just in case there's any confusion there. Okay, any other questions about that one? Okay, now let's go ahead and look at the tangent one. I'll go ahead and do this one for you as an example. Tangent formula just looks a little bit different, but it follows pretty similar format. First angle we'll call U, second angle we'll call V. The formula says take the tangent at the first angle, this is a plus, this is a plus. Tangent at the second angle over 1 minus tangent at the first angle times the tangent of the second angle. So one thing that's a little messier, I guess, is we know tangent values are a little harder to find. But the good news is, even if you don't have tangent values memorized, and you have to go do sine divided by cosine to figure out that the tangent of 45 degrees is 1, even if you have to do that, you get to use it at least twice. Tangent of 45 is on here twice. And same with the tangent of 30 degrees. Maybe you have to do sine divided by cosine there, but at least whatever you get to use it twice. So on these question types, the back of the book is going to have their answers rationalized. So if you want your answer to match up with what the web calc chat or whatever the online textbook checking thing is called, you're going to have to rationalize. I'm not going to take off if you don't rationalize, because I'm just not real interested in that right now. But that being said, you should at least deal with your complex fractions. You should never leave smaller fractions within a bigger fraction. So I'd really like to multiply this by 3. So that means in order to do that, you better multiply everything by 3. And that's actually good here. So I'm okay with you stopping with 3 plus the square root of 3 over 3 minus the square root of 3. Again, if you want it to match with what the back of the book says, they're going to multiply the top and the bottom by 3 plus the square root of 3 on top and bottom. And it makes the question a little bit longer, not really necessary, so I would stop there. But again, please don't, just multiply everything by 3 so that you don't have complex fraction. It's an easy step. All right, so now we're moving on. We got 2 other question types we're going to look at. What if it's not a unit circle type question like number 2? Notice we're not given an angle that's on the unit circle. Instead, we're given a sine and a cosine ratio. And then we're going to do a couple where we solve equations, and that will be our practice for today. So I'm going to do A, and I'm going to ask you to practice it on B. So A says, find the sine of u minus v. Okay, so without reading any directions, any of that stuff, I know from the formula, sine of u minus v would be the sine of the first angle, cosine of the second, minus the sine of the second, cosine of the first. I have the formula memorized. Now I guess I go up here and look at my information and I say, okay, sine of u, not a big deal. They told me that was a -4/5. Ready to go. Cosine of v, hey, that one's also given to me. That's 5/13. Okay, what about the sine of v though? They didn't tell me what that was, so how am I supposed to figure it out? So last semester, if something didn't end up being a unit circle question, you remember how most of the time you had to sketch a triangle? Okay, it's the same thing here, and that's what they're trying to tell you in the directions. Here's my angle U in quadrant 4. Here's my angle V in quadrant 4. U has a sine of -4/5. Cosine of V is 5/13. Pythagorean theorem or Pythagorean triples to figure out that this is a 3, 4, 5 triangle. Pythagorean theorem or Pythagorean triple to figure out that this is a 5 blank 13. You guys know that one?
7.
That's 12. 5, 12, 13. But the number one mistake, and I know I bugged y'all to death about this last semester, but it's still the number one mistake. Pythagorean theorem has no idea that you're meaning to go down. Pythagorean triples have no idea about direction either. And if you don't make that 12 a negative, then the next work that I'm about to do would be wrong. So, opposite over hypotenuse from V, adjacent over hypotenuse from U. My ratios look different. They're not ratios I'm super familiar with, at least not unit circle familiar with. But I'm going to finish it the same way. I'm going to multiply these. Going to multiply those. And then I'm going to go ahead and add them together. -20 plus 16 plus 36 would be 16. So 16 65ths. Now this one I have no way to check. I can't just like plug the original question in and see a decimal and then compare this decimal. All you can do is go back and make sure you use the right formula, make sure you plugged them in right, make sure you didn't forget negatives, make sure you didn't forget negatives. You should always look back at your stuff like that before you turn it in. Okay, B is trying to mess with you a little bit by switching these around, but this is still the first angle and that's still the second angle. In fact, adding angles, the order that you add things doesn't matter, so you could even switch them around if you really cared to. But I'd like you to try that one and see how you do, since this is the last one of these that we'll look at together. So beginning to end, formula, plug in the values, and arithmetic, and final answer. Okay, so since I had already sketched the triangles for you, I kind of did a big part of the work here. But just trying to apply the formula. Again, I don't necessarily memorize the formulas as U's and V's. I just think of first angle, second angle. This formula likes to say the cosine of the first angle times the cosine of the second angle. So what? The first angle is V and the second angle is U. Like, that's not a big deal. Opposite sine, sine of the first angle, then sine of the second angle. So from V, here's its cosine, adjacent over hypotenuse. U, cosine, adjacent over hypotenuse still. Sine, adjacent over hypotenuse, or opposite over hypotenuse, and then U, opposite over hypotenuse. So it looks like you had 15/65 minus 48/65. So in the end, negative 33/65. Is that what you ended up with? Okay, so let me leave it up for a moment. Make corrections if you need to. And ask anything that you want some clarification on. Okay there? So just a different way to use these formulas. That's not necessarily about unit circle angles. Okay, and then the last skill that we're going to practice is solving some equations. So we did this last semester as well. Some equations where you wouldn't want to just sit by and just trying to guess and check stuff. You want to use some algebra to be able to solve these. So 3 and 4, going to do the same thing. I'm going to do 3 as an example for you and then ask you to do 4 as guided practice. Now, I would understand, if we do end up having semester tests this semester, I think they haven't officially decided one way or another. I'd understand maybe you struggle a little bit more on starting this question then, but right now this section is about these new formulas. So you should be looking for ways to apply these new formulas. So when I look at this, I say, okay, well that's the new sum formula for sine. It says sine of the first, cosine of the second, sine of the second, cosine of the first. Doesn't matter that some of it's a variable and some of it's a number. It's going to plug it in. Worry about that stuff later. Okay, then I've got a plus sign. Okay, and then I've got another one of our new formulas. I had to use it twice. This is the difference for sine. So sine of the first, cosine of the second. Keep the sign the same. Sine of the second, cosine of the first. And in the end, that stuff's supposed to be equal to the square root of 3 over 2. So at first glance, it looks like we made the question more complicated, not less complicated. But notice what happens here. Some of this stuff's going to cancel out. I've got a plus sine of pi over 6 cosine x and a minus sine pi over 6 cosine x. So I don't know the size of those, but I know they're equal and opposite, so they're going to go to 0. And then these are the same thing. So a sine x cosine pi over 6 plus a sine x cosine pi over 6 means I've got 2 of them. 2 sine x cosine pi over 6. So I'm really just combining like terms. Okay, now the order that you finish this in, you got a few different choices, but at some point you need to say, all right, I know the cosine at pi over 6 from the unit circle is square root of 3 over 2. And then, I don't know, you could start moving stuff to the other side if you wanted to. I would probably reduce these. Dividing by 2 and multiplying by 2 cancel out. Then I want to divide this side by the square root of 3, so I'll divide this side by the square root of 3. And what's left is sine is a half. So, where is sine a half between 0 and 2 pi? Pi over 6 and 5 pi over 6. Those are the solutions to that equation. which means I should be able to plug them in, and it makes that original equation true. So, of course, with the calculator, that would be a good idea to do that. So, this is definitely the most involved, a little bit harder question, but I used the formula here in black. I underlined this red so you can see where I used the second formula. The rest I just copied down. Combine like terms to get to here. Change this to square root of 3 over 2 because I know that value from the unit circle. And then I just simplified, moved over what I needed to move over, and then I thought about where this was true between 0 and 2 pi. So, using that as a guide, I'd like you to try that on question 4, please. Start it off, and then when you get stuck, look at what I did on question 3. Should be a similar step for you. So if you're impatient here, remember that you should be able to plug your answers into the original equation, and if it doesn't make it true, then it can't be right. But to do this, you should have applied the formula here. Then you have a minus sign. You should have applied the formula here. Sine of the first, cosine of the second, sine of the second, cosine of the first, and then in the end it's supposed to equal 1. So all that's colored to kind of help you see that. Now, what I currently have written down is not actually accurate. So you may not have caught that because it's an easy thing to miss. But do you see how this is minus all of this? When you split apart the formula, you don't get to just say, well, it's minus the first part of the formula. No, it's minus all of this, just like this was minus all of that. So make sure that you don't just subtract the first term and then end up subtracting the second term. You actually want to add the second term. So now this and this cancel out, a positive and a negative. And this, when you distribute this, those are both the same thing. So you get 2 of these. That's supposed to equal 1. Be careful with the negative sign. It goes to all of that sign function. So even if you split it apart with the formula, it's still minus all of that. Okay, at some point you needed to change this to square root of 2 over 2. I guess you don't have to do it right here, but you've got some options. At some point, those are going to cancel. And at some point, you need to divide both sides by the square root of 2. And before you go to the unit circle, you probably want to rationalize it to make it look familiar. Cosine is square root of 2 over 2 at pi over 4 and also 7 pi over 4. It's the only time between 0 and 2 pi. So again, if you stored this in your calculator for x, you should be able to type in this big mess to the left, hit enter, and it should give you 1. Store this in your calculator as x, type all that big mess in your calculator, hit enter, and it should give you 1. If you got something else, because maybe you forgot that you didn't deal with that negative sign correctly, then that's what I would recommend moving forward. Make sure you check with those. Okay, so same thing. Let me give you a chance to speak up and ask for clarification. You need it? Yes.
So when you're plugging back into the equation, would you plug in square root of 2 over 2 or one of the angle answers?
One of the angle answers. If you're saying pi over 4 is a solution, that means for that, if you were to substitute that in for x, it should make this a true statement. And it's actually pretty easy to do in your head too, because if you added these, if I just did pi over 4 as an example, this would end up being the sine of pi over 2, which is 1, minus, if I plugged it in here, this would be the sine of 0, which is 0. So, I don't know, 1 minus 0 is going to be 1. I guess I don't really need a calculator to plug that one in and check. Pretty easy to do by hand.